Hi everyone, welcome to our talk on Meta capacity planning for AI training hardware. My name is Rahul Rai and I'm a PM on Meta's capacity infra team. Today I'm joined by Genevieve, who's also a PM on our team. In this talk, we'll share how Meta manages AI training fleet at scale, and towards the end, I'll give you a sneak peek of how a product like Threads would use AI foundations built by the infra team to manage their launches and their growth. So what is MCP? MCP stands for Meta Capacity Planning. Meta Capacity Planning essentially is a new process of planning with usage and cost attribution to products such as Facebook, Instagram, and WhatsApp. This was a huge change to our capacity planning process to make sure businesses can make ROI-based decisions. Let's look at this new model in action now. Internally at Meta, we divide our users into three key personas. There's products on the left, platforms in the middle, and then there's infra, which maintains all this common piping as well as foundational elements. Pre-MCP, we could evaluate the cost of running a specific platform like data warehouse, but we didn't know how much of this cost could be attributed to a specific product like Instagram. Infra's job was to forecast growth and keep up with the growth as our products grew. Now with MCP, infra is no longer in the business of forecasting. Products forecast their demand because they are in the best position to tell us how their products will roll out and grow with time. Platforms will tell us what is needed to fulfill this kind of demand from products, and infra's job is to forecast hardware performance as well as fulfill capacity promises we made to the products. We also maintain the common piping and common language you see here. So how does this end-to-end flywheel work? Products have to demand their forecast on what they need, when they need it by, and how much of it. Platforms are required to instrument their usage so that when somebody calls into a platform, we can accurately attribute usage and cost. Our tooling helps products build a quarterly plan that is reviewed with leadership, and once approved, we place the order for racks and stacks for data centers. As we receive the racks, they are set up and brought online in our fleet, and the demands that platform had asked for is fulfilled. The whole process is now orchestrated by the central capacity team, which is who we are. And later in the talk, I'll show you how this end-to-end workflow works for a new launch like Threads. Here's a quick agenda for the remainder of our talk. What led us, however, to rethink this entire end-to-end capacity planning process? Two words: growth, and complexity. Like many of our industry counterparts, we faced a huge pandemic era growth in usage, resulting in a capacity crunch, which has continued even post-pandemic. Meta had to rethink capacity planning due to the various growth vectors and constraints that come with such scale. Four pillars that led us to rethink this process. The first one, organic growth. This comes from the newer data centers that we're building. The data centers are becoming bigger and bigger as we scale up our operations. Inorganic growth comes from new products being launched, such as Threads, which already has over 175 million monthly active users in under 1 year. Industry changes. In the last 2 years, there's been a huge change and switch towards AGI and LLM. So you have to keep up with that kind of demand, along with the pressure of using the most expensive hardware, GPUs, for scaling up your AI efforts, as well as the budgetary and financial constraints that came after the year of efficiency post-pandemic era. Now let's look at two of these and how they manifest in practice. Data centers. The bigger we build them, the more power they'll use to operate. We have to take the power usage into account as we price the minimum sellable units by platforms. So the bigger the data center, the more different dimensions you have to take into account as you build the customer. Regions. We continuously are expanding on regions because our footprint is global. And as we exponentially grow in regions, the complexity of cross-network and cross-specific costs come into the picture. So these are some high-level areas where Meta has to deal with a lot of complexity at scale. Let's go into some specifics of why we wanted to talk about AI training here today. So in addition to this growth in the last couple of years, we have seen a huge rise in AI and LLMs, which further compounds the complexity in planning large-scale capacity efforts. Let's understand a bit more of why AI is more complicated than other areas of non-AI systems. What makes capacity planning for AI training more interesting is the fact it is a fundamental building block for critical efforts like LLMs and AGI. AI training and hardware also use the most expensive resource, which are GPUs. And it is fundamentally a more complex ecosystem than just inference or any non-AI capacity product growth. Because of these three factors, it's even more critical for us to effectively use AI training hardware. We talked about how growth and constraint led us to rethink the overall meta capacity planning in the last couple of years. At the same time, with over 3 billion daily active users, Meta is one of the few companies that has to deal with compounding complexity due to this AI boom. We have to maintain our current users and provide them a great experience, while at the same time scale up our AI efforts. Now let's look at how growth and constraints specifically apply to managing AI training fleet at scale. So the first one, the biggest driver of our constraints is the fact that we have increased GPU demand across the industry. We have seen that from how NVIDIA has done in the last few years, and providers just can't keep up with the rising demand. That leads to the second point here, which is evolving hardware landscape. Since NVIDIA is not able to keep up with the demand, we have now a multi-vendor fleet, a heterogeneous fleet where we have NVIDIA, MTI, and even our own silicon from Meta. So today we operate a multi-vendor fleet with different hardware types, and we have to abstract that from the products so they don't need to worry about this complexity. Evolving supporting services. AI training does not work in isolation. You need both hardware accelerator as well as supporting services for the data and the storage needs. So you have to make sure as the hardwares expand, the supporting services expand with the same set of heterogeneous complexities. Along comes regionalization constraints because AI training model, as it goes along, needs the data on top of which it is trained to be co-located. We don't want our AI training zones to be fragmented. As a result, we have to make sure both the supporting services as well as the accelerators are co-located. These themes pose a scaling challenge with respect to how we plan, regionalize, fulfill, and operate our training fleet. Now let's look at two of these in concrete numbers. 600K GPUs by end of 2024, not all of them are coming from one single vendor, so we have a pretty large, pretty expensive heterogeneous fleet. Since NVIDIA's GPUs are not enough, we have AMD in the fleet as well as Meta's own silicon. Given how performance characteristics of these differ, we need to operate this multi-vendor fleet with minimum friction for our products. So now that we know that there are complexities around AI training fleet, let's look at how Meta solves these challenges. Let's hear it from Genevieve of how we had to rethink our AI training strategy at Meta, keeping capacity planning at its core.
Thank you, Rahul. So now that Rahul has covered what MCP, meta capacity planning, is, as well as the challenges that we're facing, let's talk about how Meta enables capacity planning of AI training hardware at scale. The infra capacity team had to rethink the entire end-to-end workflow for training AI jobs and how it connects to capacity planning. We shifted our AI training strategy into a model whereby we capture the product's intent for capacity. So in other words, this is the use case for their AI training needs. And in return, Infra then provides them with capacity solutions on a sliding scale, balancing efficiency and fungibility depending on the use cases that they provided to us. The end-to-end workflow for the AI training strategy involves tight collaboration between the three personas that we talked about, between the products like Facebook, Instagram, and WhatsApp, the platforms like data warehouse, Scribe, or storage, and infra capacity. Infra capacity is unique in the sense that we're close to our customers. There's both vertical and horizontal integration across all three spaces that the personas are involved in. The roles that our main personas have can be mapped into three distinct segments of the AI training strategy. First, we have the products, like Instagram and Facebook. They're involved in the user experience segment of our strategy. They provide us with their forecasted multi-year demand in InfraCloud portal. This is what they want for X number of years. Platforms come in the middle portion of the strategy. Their resources are the underlying components that the solvers and the runtime components need to manage. This is the second segment of our AI training strategy. The solvers and the runtime components process the wants from the products and turn them into what they will get. Products come in again in the later user experience portion of the pipeline. They run their AI training jobs and experiments on another user interface called Machine Learning Hub, or ML Hub. So where does infra capacity come in? Infra capacity comes in the third segment. We provide the AI foundations that all of the above runs on, playing a part across all stages of the pipeline. Let's dig into AI foundations a little bit more. AI foundations is the foundational layer that infra capacity manages and defines. We ensure that there's consistent and robust systems in place across the board. So what did we do? We first determined that we needed to set in place capacity contracts between the products, platforms, and infra capacity. So this would be capacity contracts between Instagram, data warehouse, and infra. Capacity contracts are similar to purchase orders. They capture the list of buyers and sellers, buyers being Instagram and sellers being data warehouses, the resources or services being purchased, the quantities, the pricing, and even logistical information in the form of regionalization and placement details. These contracts help increase Instagram's control of their resource needs. The contract is a promise that infra and platforms make to Instagram to fulfill their capacity. Earlier on, Rahul also mentioned that one of the complexities for AI training at scale is the increase in heterogeneity of training hardware with the introduction of many variants of accelerators. So a second AI foundational construct that we put in place was setting up an ecosystem-wide data structure for all types of resources, including the AI accelerator resources. This is used throughout the entire meta capacity planning ecosystem. The data structure is used by Instagram and in the solver and the runtime components as well. The capacity contracts and the data structure provides us with uniformity at scale. Both will ensure that there are less changes needed across the system to support AI training capacity management. So for example, if NVIDIA decides to release a new hardware accelerator next year, we don't have to rewrite the data structure just for that accelerator. This information is abstracted out in our capacity contracts in our data structure. A third AI foundation layer is the management of supporting service resources through what we call product demand calculators. Again, Rahul had earlier mentioned that there's an increase in heterogeneity of supporting services when AI training hardware scales. This is a compounding complexity as each AI training hardware has multiple variants of supporting services attached to it. To manage this at scale, we have platforms create calculators for the services or the resources that they provide. Products will then use these calculators to understand how much of data warehouses resources that they will need in capacity forecasting. Similar to the capacity contracts, these calculators increase Instagram's control over their resourcing needs. A fourth item in AI Foundations is the update of our regionalization strategy for AI training. This ties into the fourth complexity we face at scale that Rahul mentioned earlier, global regionalization constraints. Firstly, instead of having a cross-regional network, we concentrate our accelerators into fewer regions. This reduces the cross-region network bandwidth needed to replicate data. Secondly, instead of having fungible resources, we're moving to pre-regionalized resources. This optimizes the regional placement of the AI accelerators, the supporting services, and associated data. All of these will help minimize costs. Products like Instagram will again have increased control by being able to provide infra with their regionalization intent. They will be able to help decide on the co-location of supporting services with their accelerators. We now move on to the fifth and the sixth AI foundational layer, resource management and resource accounting. To manage resources, we put in place a structured resource management hierarchy called budgeting hierarchy. This hierarchy defines how resources are managed and allocated down the chain. Similar to how maybe you might have a biology department with sub-departments and sub-sub-departments with a bunch of resources that you want to allocate accordingly, we had our product groups like Instagram define their departmental hierarchy. This hierarchy, along with the capacity contracts that we talked about earlier, will help to define the resource quotas that are trickled down the departmental chain. The quotas that are put in place per resource, along with the knowledge of usage information, is surfaced in InfraCloud Portal. All of these allows for accounting and management of our resources. Now that we've talked about the AI foundational layer, we move on to the solver and runtime components. These are the brains and the runtime components managing platform resources. Our runtime ecosystem behavior consists of 3 different parts. Each part is responsible for solving for a particular use case over a particular planning horizon. First of all, we have the Meta Capacity Planning Solver, or MCP Solver. MCP Solver is the decision maker used to solve for physical capacity planning. It regionalizes AI training capacity and reasons about long-term hardware placement. The solver is what produces the agreed-upon capacity contracts between Instagram and data warehouse. The output is where we would place the racks. The MCP solver runs on a quarterly cadence. Next, we have Tetris. Tetris is a data placement solver. It produces an optimal data placement plan, co-locating data with the accelerators for training demand. This ensures that there's no cross-Atlantic network costs involved. Tetris honors the quotas set in the capacity contracts and will follow the regionalization details as well. Tetris runs on an hourly or daily basis. Lastly, we have MAST. MAST is a job placement solver running in real time. It determines the ordering of all the AI training jobs based on priority and global usage or quota information. It places jobs into regions based on the capacity contracts and based on availability. Now that we've talked about AI foundations that Infra has built, along with the brains of the operations that manages the resources, how do we surface relevant information to our product groups? We built user experiences for the products to submit their demand and manage their AI training models. We focus on these 4 user interfaces in AI capacity management. Firstly, the Infra Cloud Portal, which I've mentioned before. This provides a unified tooling experience across the capacity management space. It's where products like Instagram come to buy, sell, exchange, replace, and view the capacity. Then we have product demand capture user experience. This product demand capture is nested within Infra Cloud Portal. It ensures that the AI hardware orders that are placed are within the constraints of available hardware, financial limits, available data center space, and available power. Thirdly, we have the product demand calculators that I mentioned earlier as well. If you recall, the platforms like Data Warehouse define these calculators, and the output of these are the resources that the product will consume. All of these 3 will help Instagram provide us with their hardware demand and captures the intent of their training jobs. Next, we have Machine Learning Hub. Machine Learning Hub is another user experience that has been built specifically for machine learning engineers at Meta to interact with their AI training workloads. ML Hub provides the functionalities for users to inspect their job state, resource consumptions, and promote or demote certain jobs in the job queue. All in all, our user experience caters all the way from the top to the bottom, from planners to machine learning engineers to infra engineers as well. So, this wraps up the end-to-end pipeline for the AI training capacity management strategy at Meta. I'll now hand this over to Rahul again to talk about threads.
Thanks, Jen. And now let's look at a real-world example of how the AI Foundations work that Jen mentioned can be used by threads when they launch a new product, a new scope in a new region, etc. So threads as a customer comes to InfraCloud Portal with the intent of getting capacity to train their new ML models when the demand cycle opens. To input their demand, threads has to tell us what accelerators they need, how many, how long, and what kind of supporting services they require. Our tooling allows most of the users to pick the right default so that they don't have to tweak around with the system, and most customers will just pick the defaults and go with it. If you're a power user and you have specific needs when it comes to supporting services or specific regional preferences, you can make those changes as part of the tooling experience. Once the input have been decided, we lock the plan and submit to leadership for approval. Once approved, this plan becomes the new capacity contract for threads. This is what Infra promises threads with certain SLOs. So what you see on the slide here is a contract composed of AI training, which is what thread needs, for a specific accelerator type with specific storage supporting services, regionalized altogether based on the customer's requirement. After this comes the ordering setup process for the new racks. Once the rack lands and they're brought up in the fleet, we know how much threads had asked for. We bundle the accelerators with the required supporting services and co-locate them in a specific region with the help of our solvers, Tetris, and MAST. Since resource accounting and resource management is built into the system, when an ML engineer is running a job through ML Hub, they can choose where to build this job to. That's where they will choose the option of build this to threads, and that way they can use the capacity that was previously demanded by threads. ML engineers working on training model for threads can now use this heterogeneous set of GPUs and required servers to train their models without having to understand the complexity of whether I'm using NVIDIA, AMD, or some other silicon. They also don't have to worry about scheduling the jobs or making sure the data is in the right location because infra takes care of that. At the same time, since capacity planning is built into the training strategy, we are now able to train model more efficiently by co-locating services and accelerators as required by our customer, so we don't pay any cross-network costs. This is how infra teams like us deliver on the promise made to products like Threads. So, in closing, quite a few exciting things coming down the line for capacity at infra. As you might imagine, we do things a little bit differently since we are very close to our customers and we understand the requirements really well. We can run a very lean cloud operation with very minimal buffers. MCP also started as a need coming out of the pandemic era, but now it has become a want. Leadership wants MCP process to make sure they can make ROI-based decisions. It helps products better plan their releases and launches, and it helps platforms improve their experience without having to deal with individual customers or individual requirements from Instagram, Facebook, etc. In essence, it's a great and interesting place to be for a PM because we have to deal with complexity all the way from a customer's application layer as a user using Instagram and Threads, all the way down to where you order stacks and racks and you have to understand how DC compliance works. So feel free to reach out to us and join us. Thank you.